This project started off as a pretty normal MMX machine with a slight overclock in a pretty sweet period correct vintage case. But you guys know me, a slight overclock isn't going to do it for me. So on today's video we're going to overclock the living daylights out of a Pentium MMX. To reach the speeds we're going for today we have previously repaired a trash-picked ASUS P5A, one of the fastest SuperSocket 7 boards. To get it to working condition we had to replace the CPU sockets and one of the SIM slots. And we have also done a full polymod. Let's start with a quick benchmark so we have something to compare with. For this build I have picked a Voodoo 3 card, 128 MB of RAM and a regular SD card. And set to stock speed we're getting 53.5 FPS. So that's already playable, but definitely not remarkable. The significance of the Pentium MMX was that it introduced 57 new multimedia instructions, offering over 60% higher performance on media benchmarks compared to the regular Pentium. Unfortunately, the desktop version only went to 233 MHz, but Intel actually also made a faster Tillamook Mobile MMX. These are not just slightly faster, but apparently they also overclock really well. They aren't designed to work on a desktop motherboard, but some guys on Vogons figured out how to mod this chip. So let's solder some wires to this oddball CPU and see how fast it will go. Okay, let's start with a somewhat tricky one first. Down in this corner. It's a bit tricky because it crosses two pads. And with one side soldered and the other side cut to size. You can go ahead and solder the other side. This wire I think is for the level 2 cache. Actually the second wire too crosses one of the pads, so I have sleeved it with PTFE. I use PTFE because it doesn't melt, and on tiny wires like this it's an absolute must. And the problem when soldering short wires is that when you solder one end it's very easy to desolder the other end. So let's make sure they are firmly attached. And this bodge wire here I think is for dual rail voltage detection. And the last wire should be a bit easier, since it's not crossing any pads. And this tiny little wire here is for the 4x multiplier. Okay, let's clean and inspect. By the way, I should mention that the regular MMX was also made in this package. So if you're looking for one of these, you need to check the numbers underneath and make sure you got the right chip. Okay, chip has been cleaned and inspected. Everything looks good. This wire here is so small it's barely visible. So the ASUS P5A's claim to fame is that it was one of the fastest SuperSocket 7 boards, while a typical MMX board would do 66 MHz FSB. And depending on where you read, this board officially supports 100 or 120 MHz. And then it actually also has some undocumented jumper settings that will take this board to 150, which is pretty crazy. I have replaced all the caps with poly caps to get perfect smooth power, and hopefully this will make a difference. And if nothing else, at least they will never leak. For this first test I have set the jumpers for 100 MHz FSB. I'm not sure how to set the multiplier here, since we have soldered the bodge wire for 4x on the CPU. So for this first test I'm just going to leave it at 3x and we'll check and see how the board behaves. For this first test I have set the jumpers for V-core to 2 volts. Unlike the regular MMX, this CPU only requires 1.9 volts. But we are going to overclock, so we're probably going to increase it even more. I have set the I/O voltage to the lowest possible option, which unfortunately is 3.5 volts, which is way too high, but that's the lowest option we have. Okay. Time for a test. Here goes. Okay, the fan spun up. Oh, and it's posting, running at 300 MHz. So let's jump into the BIOS. Okay, the CPU is running at 58C. V-core is 2 volts. So let's reboot again. Unfortunately, we are getting this error. Hardware monitor found an error. Enter power management setup for details. So I'm not sure if it's referring to this error here. It does correctly say that we are running at 2 volts. But why is this an error? I'm not sure, so let's try to boot the machine and see what happens. Okay, and it's stable enough to run Windows. But let's switch to DOS. And go to SpeedSys. Okay, and in here we can see that it's running a Tillamook at 300 MHz. FSB is correctly 100. So everything is looking okay in here. We are running at 3x. And both level 1 and level 2 cache seems to be working too. So this is looking good. So let's run Quake instead. We're getting a score of 72.7. Wow, so easy to overclock, thanks to the mod figured out by the Vogons. But we are of course going to push this machine to its limits. Okay, so 300 MHz is nothing for this CPU. Let's push it some more. But first I'd like to thank my favorite sponsor, PCB. Aside from making excellent PCBs, as we have seen in many of my videos, they also do CNC machining, 3D printing and PCB assembly. Perfect for prototyping and vintage computer restorations like this one. If you need some help designing your next PCB, check out their new PCB design surveys. Get an instant quote now for your next project at PCBWay.com. Thank you PCBWay for supporting this channel. Well, the jumper settings for 4X gave me a bit of a headache, because there is no such option for the MMX. But according to Google, we should be able to use the settings for the K6 too. So let's give that a try. Here goes. Oh, it posts. But now it thinks it's running at 200 MHz. And we still have that power management error. Let's check in SpeedSys. Okay, and according to SpeedSys, we're now running at 66 MHz times 3. So this is completely off. And we have a significantly lower score. So those settings are not correct. Google is wrong. Okay, I want my trial and error. Now this machine is running at 350 with the jumper settings set to 3.5x. And it's stable enough for Windows. Let's check in SpeedSys. And it is indeed running at 350 with FSB 100. And cache is still working. Wow, so from 266 to 350. This is quite overclock. Let's run some Quake and see if it's stable. These benchmarks only takes a few seconds. Okay, and we have increased the score to 78.1 from 52. That is quite a performance increase. I'll mess around some more with the jumper settings and see if I can figure this out. That error on every boot is super annoying. So let's try to load the default settings. See what happens. It's counting up the RAM very slowly. So I'm gonna have to change that setting. Okay, that actually got rid of the error. But now we have a floppy disk fail. That should be easy to fix. We'll just set the floppy disk to none and save. And now the machine boots without errors. Well, I have tried all the settings I can think of, but unfortunately I can't make it run at 4x. But I don't think we're going to get the best performance at 4x anyways. But if someone watching this has been able to make it work, then please share how you set your jumpers for the multiplier. And we'll proceed by increasing the FSB instead. Okay, increase the FSB to 105. So we're now running at 366 MHz. Okay, and it actually hanged. So it won't boot to Windows. Well, in that case, let's increase the voltage from 2 volts to 2.1. Yeah, let's try again. No, not quite enough, so it still hangs. So let's try out 2.2 volts next. Okay, next I did a whole array of tests. Too boring to watch, so I skipped ahead here a bit. It doesn't seem to be happy with the in-between speeds. So now we're actually running at 120 MHz FSB, giving us a speed of 420. But the system seems to be a bit confused here. So it seems to think that FSB is 105. So I'm not sure what to think here. Cache is still working fine. Well, I guess we should try Quake and see what score we get. So we got 78.1 at 100. Oh wow, now we're getting 92.4. Holy cow, that is quite a performance increase. So we started off at 50 something, so we have almost double the speed of this board. Well, according to system information, it is running at 420 MHz too. And according to check CPU, it's also running at 419.8. Well, I guess we should try to go even faster. Let's try with the FSP at 124. Oh no, it just completely hanged right away. Well, since it didn't like some of the in-between speeds, let's go completely bananas and run it at 466. So 3.5 times 133. Well, as expected, it completely crashed right away. So 420 seems to be the limit for the Tillamook 266 MMX. So I've been running this machine for quite a while now, and it seems to be quite happy at 70C, which is totally acceptable for an extremely overclocked machine, especially with that dinky little fan. And I think I figured out that weird error. It seems to be the V-core voltage here. I have it set to 2.8 volts now, and it's giving me an error. And if I set it to ignore, I get rid of that error. But let's not. So next I'm going to try to lower the V-core voltage and see if I can make it run stable at a lower voltage. Okay, I took the voltage all the way down to 2.4, and then Windows crashed. So 2.5 volts V-core is what we seem to need to run the MMX at 420. Before we continue this build, we have to replace the fans, because this board is incredibly noisy. I'll see if I can find some longer screws and install a Noctua NFA420. This should also improve the cooling quite significantly. Actually, that was a lot easier than I thought. Regular fan screws were too long, but regular PC screws apparently fit perfectly. They're obviously not long enough, but installed down here, they fit perfectly. So that could be a useful trick to know. That fan is super nice and quiet. I can barely hear that fan. Awesome. But the voodoo card is going to be a bit trickier. Noctua is making 40mm fans and 60mm fans, but they don't make 50mm fans, which is a shame. If you have a recommendation for a nice and silent 50mm fan, then please share. I don't really have an easy way to install a 40 or 60mm fan on this card, because it only has holes that line up for a 50mm fan. I removed the sticker at the back. Now let's see what happens if we place a drop of machine oil on the bearings. It went completely silent. Wow, that made a huge difference. Well, the sticker got destroyed, so I used some Kapton tape to cover up that bearing. I want this build to be really neat, so I grabbed the leftover extension cable from one of my Noctua fans and replaced this ugly thing here. So now the board looks really nice and tidy, and very nice and quiet. I also noticed that when I tilt the board, the way it's going to be installed in the machine, I'm getting a lot less noise from this fan. So it doesn't seem to be happy running standing up like this. And next I did a whole bunch of tests and really pushed this board with tons of benchmarks, and actually managed to crash it once. So I decided to increase the voltage to 2.6. Now it's super stable and I can't make it crash. So V-core 2.6 seems to be perfect. And the CPU temperature actually went down from around 70 to about 60 with that Noctua fan installed. So it really made a difference. And now I can set this to ignore, so we don't get that error on every boot. While I was working on this project, another YouTuber made a video where he made a really neat mod to his P5A board. So before we install this motherboard into that awesome chassis, let's make that mod to this board too. So one of the quirks with this board is that the lowest you can set the I/O voltage is 3.5 volts, which is a bit too high. And the CPU that we're running on this board prefers an even lower voltage. So this mod totally makes sense when using a P5A together with a Tillamook. I'll put something on the screen here so you can find that video. And a short version of it is that he replaced R131 to change the reference voltage for this chip here. And that way he was able to lower the voltage. A very simple mod, easy to do and totally worth it for me. I am however going to make this slightly differently. Instead of replacing that resistor, I'm going to replace it with a tiny little trim pot. The screw hole here is not in use, at least not in my case. So there's plenty of room to install it here and connect it to these two pads. So let's add a splash of flux to that resistor. And then I'm going to remove it with my tweezers. So I have bent the legs on the trim pot. And then I'm going to glue it to the board and solder the two connections here to where the resistor was installed. Okay, I aligned and glued the trim pot to the board. I use regular hot glue, so it can easily be removed if I ever want to go back to stock. And with some flux and a small tip, we can solder the two legs to the pads of the resistor. This is a really tight spot, so I managed to get a bridge. Let's remove it with some flux. Like so. I'll do a proper inspection of the solder joints before we test the board again. Okay, I'm running some tests here with regular MMX, just in case I mess something up. So V-core is 2.8 and IO voltage 3.3 as it should. Now let's turn this pot 3.2, 3.1, 3 volts, 2.9 and so on. Awesome! That is a really neat mod. If you're messing around with Tillamook, I'll set it to 3 volts and then I'll run some benchmarks and see if it's stable. Okay, Windows gave me an error on every boot, so I cramped up the IO voltage to 3.1 and now Windows works again. So 3 volts wasn't quite enough and Quake is running without any issues at 420 MHz. So I think we're all good, but I'll do some retro gaming when I'm done with this video, and if I have to increase any of the voltages, I will leave some information in the description below. A really neat feature of this case is that you can install the motherboard and all the cards and test everything before you slide the whole package inside the machine. And that's exactly what I did. I have installed a Sound Blaster, and the USB card is an absolute must for a build like this. But strangely enough, I couldn't make it work with one of these NEC-based USB cards. So I tried one of these VIA-based cards instead, and that worked perfectly. That is kind of funny, because it's the opposite of the issue we had when we did the dual Pentium 3 VP6 project a while back. On that machine, the NEC card worked, but not this VIA card. So I guess some chipsets are more compatible with one or the other. I wasn't even able to boot Windows with that NEC card. But anyways, that has been sorted, so we can install the motherboard. And the installation is super easy. Just slide the whole thing into the case, with cards and all. Super nifty case. Okay, next I ran some tests, and unfortunately we've got 2 more issues to fix. So first of all, I can't turn the machine off. When I turn Windows off, the machine just reboots. So for whatever reason, our motherboard doesn't like the AT power supply installed in this case. So we need to convert this case into an ATX case. And that means we can't use the power switch. So first of all, it belongs to this power supply. And secondly, it's also a latching switch. So not useful for an ATX power supply. I spent about an hour online trying to find an ATX switch that fits into an AT case. And I sort of found one switch that might work, but it was kind of pricey with shipping. So instead I went through my stash and found an acrylic sheet. And then I used this tool here. And I cut this piece to size. And then I drilled some holes here. And then I found these switches in my stash. These are super cheap and can be found on all the usual places. And the switch, of course, fits the middle hole. And hopefully the other 2 holes will line up with these 2 screws. And they did, but I had to use 2 longer screws and a couple of nuts from my standoff kit. So now we have an ATX power switch. On the inside of the front panel, the power switch has a plunger that hopefully will line up with our new switch. Well, it did, after some adjustments. So apparently that's a relatively easy way to convert an AT case into an ATX case. I soldered some extension cables so it would reach where it should on the motherboard. Okay, problem solved. This case is now an ATX case. Oh, perhaps I should have mentioned, this board has both connectors, so it can be used with an AT or ATX power supply. But for whatever reason, it doesn't seem to like this AT power supply. Anyways, problem solved. And this machine can now be turned off. Next I decided to push this board a bit and decided to play Sims. I deliberately picked this game because the recommended specs is a Pentium 2, so this should at least give some challenge to this MMX. And the game runs perfectly fine, but unfortunately the whole PC crashed after about half an hour. I tried again and it crashed again, so now I have cranked up the V-core to 2.7. So I guess I'll play some more now and skip ahead here. Okay, we finally have a stable system. 2.7 wasn't quite enough, so I cranked it up to 2.8 volts. I haven't played The Sims in decades, but apparently it's still fun, because I got hooked for hours. And if it's stable enough for hours of retro gaming, it's stable enough for me. And this is finally an MMX dream machine. But we're not done yet, because I was planning for a pretty cool case mod for this video too. Unfortunately I managed to order the wrong part, so I'll reorder some stuff and do some reading about that 4X mode. And we'll see this build on the bench again in another video. But that's all I had for you guys today. Before you leave, like, subscribe and leave a comment, and consider joining me on Patreon. And that was a good time to binge watch every single video on this channel, even the old crappy ones. Have fun, and I'll see you guys again next week.